So hi everyone, my name is Nikhil Barthwal and I'm a product manager at Google Cloud Platform. I mostly work on serverless products, Cloud Run on GKE, Knative, App Engine Flex. I'm going to talk about Knative and Cloud Run, two of the products we work with. And they're basically serverless frameworks, so you can use them to manage modern serverless workloads. And they're not actually two separate products. Knative is basically an open source version that you run on your own private cloud Kubernetes cluster, and Cloud Run is kind of the managed version. And they basically share the same API. So Knative has a reference API that Cloud Run shares. Cloud Run itself is basically two products, Cloud Run and Cloud Run on GKE. So there's actually three different products that share the same API, and you can basically run them and mix and match things any way you want. So you can have like a hybrid scenario with Knative running locally and Cloud running on the cloud, on the Google Cloud Platform. And then if you're in case using some other cloud like Azure or AWS, you can even run Cloud Run on GKE. So anyway, let me get started here. So I'll start with the serverless model. When we talk about serverless, what is serverless computing? Now, there are two different models for serverless, right? There's an operational model and then there's a programming model. So the most common features of operation is basically the benefit of serverless is all the operations is kind of taken care of by the operator, right? So you don't have any infrastructure to manage. You don't have to have any security. You only pay for what you use. These are the common characteristics of any serverless platform, whether it's Google, Amazon, AWS, Lambda, Azure Functions, whatever. And from the programmer's point of view, it's basically a collection of loosely coupled services or functions. Often it's called functions as a service, although there is some technical difference between fast and serverless. But nevertheless, for the purpose of talk, I can even refer to this as function as a service. So we have these loosely coupled functions, and they communicate with each other through events. And lastly, for the purpose of this talk, actually, the system is very open. So we are not really locking you to a vendor. This is actually not particularly true for, one of the criticisms of serverless is that there is a vendor lock-in. If you use AWS Lambda or Azure Functions, or even Google Cloud Functions for that matter, you have a vendor lock-in. But here, we'll see that we actually don't have any vendor lock-in. You can just run it anyway. I just mentioned that Knative you can run on your own local cluster. And we'll see how the vendor lock-in is actually prevented. So I'm going to start with containers. Now, containers is a fairly standard technology, right? It's basically a miniaturized virtual machine, so as to speak. And it's a miniaturized virtual machine. It's a way to package your code just about any language, any binary, any library. And there's an ecosystem of base images. So you can take like a Node.js, Python, ASP, or they're all stored in the repository. And you can pick and then you can add layers on top of it. So by and large, it's essentially a vendor agnostic way of packaging your code. And all major cloud providers provide support for containers. So you are not really logged into any vendor. You can seamlessly move around from GCP to Azure to even your own local dev machine. So that's containers, and containers have gained a lot of popularity. It's kind of an industry standard. And one of the very reasons why you use containers is, one, you avoid vendor locking here, and two, you can have multi-tenancy, right? I can have one VM with several containers or one machine with several containers. So it's a better utilization of my resources. I pay for the same machine, but I get many different, I can have many different services running on it. Of course, there are downsides to containers. Like everything, there are pros and cons, but containers are by now industry standard way of packaging your code across all major cloud providers. And then we have the containers, sure, but what is the system to orchestrate these containers, to manage these containers? So there are tons, not tons, maybe there are a couple of systems. Kubernetes is by far the most popular one, but there's Mesosphere, there's Docker Swarm. Kubernetes actually provide you with a lot of these features. Some of them are listed here: scheduling, lifecycle, scaling, etc., etc. What Kubernetes basically has is it's a descriptive way where you basically tell Kubernetes the desired state of your system, and Kubernetes would work as to bring your state to close to the desired system. Now, Kubernetes basically comes from a version, an Google internal product called Borg. So Kubernetes was basically, I wouldn't exactly say an open source version of Borg, but it was derived from Borg. The engineers who worked on Borg basically then said, let's just open source this, and they rewrote Borg code actually. So Borg was originally done in C++, and then they rewrote the Borg code in Go, and then they open sourced it, and they removed any Google proprietary stuff, and that became what we call today as Kubernetes. And Kubernetes is a widely popular project. This is the Kubernetes ecosystem. You have so many contributors, so many partners. You have Kubernetes is provided to you in Google Cloud as Google Kubernetes Engine. Azure provides Azure Kubernetes Service, AKS I think, or AKS, yeah. And then Amazon has something for Kubernetes also, Elastic Kubernetes, I don't know the full form, but they have some Kubernetes offering on their own platform. And of course, Google provides a Google flavored version of Kubernetes called GKE on-prem, which is basically the same as the Kubernetes you get on the cloud. And Kubernetes essentially can be thought of as a platform to build platform, right? So it's a great place to start, but it's never an end goal in itself. So that's Kubernetes. And Knative is one such platform. So Knative essentially brings the serverless on top of Kubernetes, and it provides you with all the building blocks of the serverless that you would need. This is a completely open source product, and I'll give you the links for that. But yeah, so we'll examine what the Knative stack would look like. But what Knative basically does is gives you a set of primitives. So there's build, taking how do you build your code from containers, from your source code to containers. There's events, because we know that functions, they communicate with each other through these events. So there is something to do events. And then there is traffic routing, which is done by serving. And Knative essentially is an open source project run by Google, Pivotal, IBM, SAP, T-Mobile, and there are a bunch of these partners. We actually meet, we have working groups and which has people from all of these industry partners, and we basically get together every week online, and we discuss the future of Kubernetes. So that's the website, discuss the features for Knative and the future direction for Knative. I have the link here, knative.dev. I invite you to check this link. So the operator view of the Knative is basically Kubernetes would abstract away all your infrastructure complexity, right? So it's kind of universally supported by all cloud vendors. It's very extensible. We talked about how Kubernetes can be used to build platforms, and because Kubernetes is provided to you as a service for all major cloud vendors, you can, in theory, run Knative there also, or you can run it on your own private cluster. So that's the Knative view from an operator's point of view. Then we talk about the interesting part, the Knative view from the developer point of view. Now, developers want to write code. What they don't want is, I don't want to handle how all that orchestration happens. I don't want to handle all the infrastructure, all the minute details of how to build the code, how to expose it to internet, etc., etc. So logging, monitoring, all those common components are provided by Kubernetes. Kubernetes basically has, we'll examine the stack in details. I think the next slide is, okay, not the next one. So we'll examine the stack for Knative. It basically has Istio, which does a lot of this network routing. So these are the major launch partners for Knative. Pivotal provides support for Knative. IBM, I think IBM Cloud Functions, or not Cloud Functions, they have some offerings. If you have a Kubernetes cluster in IBM Cloud, you can actually support Cloud Run on GKE, which is a Knative implementation for IBM Cloud. And SAP has Kaima, and Red Hat also provides you. Red Hat is actually quite actively involved in Knative project. I think we have speakers. We have a Knative Tech Talk that happens every month, and we have speakers from all of these companies that basically give talks on various aspects of Knatives, and it's broadcasted live on YouTube, so anybody is welcome to join. So this is the Knative stack, right? So we have the three basic primitives here: build, serving, eventing. And then we have the service mesh Istio, which comes with it, which, by the way, if you don't want it, you can replace it by something else. And then you have the Kubernetes underlying platform. And then you have various products built on top of it. Now, the goal of Knative was to be a very open, extendable project. So the way it's designed, these are various building blocks, but you can actually swap out these blocks and replace it with something else. When Knative started, there was this one repository. You know, Google is famous for that mono repo, everything is in one repository, which is a huge, 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 gigantic repository. And Google also started the Knative project as a single repository. And then they separated out all of these and put them in a separate repository, because it was kind of a forcing function to basically see Knative not as a product, but as a building block for, as basically something that consists of building blocks, and each building block is separate. So if I don't want the standard build, in fact, build is actually in future going away, and it's going to be replaced by Tekton. So this is what the current stack of Knative is. This is not how Knative would look like in future. Build will disappear, and Tekton pipelines, which I'm going to talk about, will actually, it's not a part of Knative project as such, but it will actually replace build. But these are various common building blocks of Knative. So let's actually examine the three basic primitives in detail. So we have the serving, right? Serving routes traffic. It can seamlessly scale up and down. When you deploy these functions are immutable in time. So what you create is you create a revision. So I deploy something, I create a new revision, so on. And then what I can do is I can have the serving split traffic. I can say 80% would go to revision 1, 20% would go to revision 2. You know, for A/B testing or for testing new features, it's actually pretty useful to split traffic. And it's a very pluggable system. You can connect to your own logging monitoring, but obviously you can use your own. Oh God, I don't know why this is. Okay, good, excellent, yeah. So that's serving. Then you have eventing. These services or functions, I kind of tend to use them interchangeably, but they are loosely coupled systems, right? They communicate with each other in an event-driven fashion. So you have event-driven premises, so you have event producers, you have the channels that connect these events, and then you have the consumers. So all that is taken care of by the Knative eventing. And finally, you have build, which I prefer not to talk too much about it because it's going to go away in future. So essentially, what it is it's going to be source code to container images on repository. It takes care of the building. And what build is actually going to be replaced on with is Tektons. And Tekton, I think there were a couple of workshops related to Tektons. So essentially, Tekton is an open source CI/CD platform implementation based on Kubernetes. So again, it emphasizes the fact that Kubernetes is essentially an underlying platform, and you build on top of it. And it's basically openly governed by Continuous Delivery Foundations. It's open source. It's currently in alpha 0.5, but we hopefully will get it beta, and finally it'll be released. So yeah, so that's Tekton pipeline. So essentially, this is Knative basically provides the base API, and there's an open source implementation. And what Knative's value today is, it's a one-step deploy. It can auto scale, and it can manage all these workloads. And like I said, it's completely open source. It runs on your own cluster. And then finally, I'm going to introduce Cloud Run. And what Cloud Run is it's basically an implementation of Knative API on a managed platform. So think of Cloud Run, even this statement is true for Knative also, but what Knative does is it's basically bridging serverless to containers. It's essentially giving you a serverless framework, or I don't know if I'll use the word framework, but basically something like a serverless system where think of an AWS Lambda, but where your functions are actually replaced by containers. That's what Cloud Run or even Knative is. So, which is great because we know that containers is industry standard. So now again comes back to the point that I'm not actually going to be locked to any particular vendor like AWS or Google or Azure, because I have container, which is a fairly standard way of doing it. Most of the people would know how to build the containers. I can build the containers local on my machine. It's an industry standard, it's open, and then I can have these containers, and then I can just scale up and scale down these containers, automatically provision everything using Cloud Run or Knative. And Cloud Run as such is basically two products. And one is Cloud Run. I like to call it Cloud Run on Borg, but Borg is not open source, it's proprietary. So that is why I removed the word on Borg and just calls it Cloud Run, but it's basically the fully managed Cloud Run version, and then there is Cloud Run on GKE. And it's often confusing to people, why do you have like multiple versions of the same thing? Well, there are obvious reasons why you would want something like that. For one, sometimes, in general, when you're moving to the cloud, what you're doing is you're giving up the control of operations to the vendor. And then, in some ways it's good because you don't have to worry about operation, you don't have to worry about management, but some way bad because you're letting the control go to somebody else. So Cloud Run and Cloud Run on GKE, that's the difference. It's a fully managed one, so you don't have to manage your own cluster, you only pay for what you use. Typical serverless, it's fully serverless, fully managed. Whereas Cloud Run on GKE, basically you have your own GKE cluster and you're running serverless on top of that. And often a commonly asked question is, why would somebody do that? And the reason why somebody do that is, for a lot of organizations, either they have a private cloud, they are running their own version of GKE on-prem, or they are using GKE anyway for something else, and they want serverless as an add-on, that supplements their existing system running on GKE. So for those scenarios, you would want to use Cloud Run on GKE. Now, Cloud Run on GKE has the advantage that it's running on the cluster. So you basically have access to those nodes on which your system is running, whereas in Cloud Run, because it's fully managed, you don't have access to that, which again comes back to the whole philosophy of moving to the cloud. You don't have to worry about operations, but you don't get to have any kind of control, or you can't do any kind of optimizations on it. We'll talk about the pricing a little bit, but for Cloud Run on GKE, you basically would kind of end up paying for your cluster, not for the usage. So it's not entirely serverless in the sense it's not strictly pay as you use because you're running the cluster. So anyhow, so these are the two platforms. I'll actually have a demo where I sort of create and show how these clusters are created and how I deploy and so on. But the essential point to remember is that this is based on Knative API. So it doesn't matter what product you choose. It doesn't matter how you mix them. At the end, your API is the same. And this is a big, big, big benefit. The reason why it is a big benefit is it gives you the freedom to run your code anywhere on a managed platform, on your Kubernetes cluster, on your local cluster. And not only can you mix and match the code and create a hybrid cloud, you can also seamlessly move workarounds. So I can take a workload running on Cloud Run on GKE and say, I don't want it to run on a cluster. I just want to be managed by somebody else, and take it to Cloud Run on GKE to Cloud Run, or take a product from Knative to Cloud Run, or vice versa, without changing a single line of code. It just would work as it is. So portability is a big factor. I mean, it tends to get confusing for people if you introduce n number of products and you say, well, there's an API for this, the API for this. It's a big pain. So this was a conscious decision made that we want compatibility across all serverless product, period. So yeah, so it's portable based on Knative API. And essentially what Cloud Run basically then gives you is it gives you a container to production in seconds. It's serverless, and it's most important, one experience wherever you want it. Whether you want it in the cloud, on your local machine, doesn't matter, but it's one experience. So I will pause and I will go for a demo here. So let's look at the code here. So what I'm going to do here is I have a simple Python file. And I'm using a Flask framework for Python. Now, Flask is a very popular one. It's also a very easy one. And what I'm trying to do is I'm trying to build a service that you would take a Word document file and it'll convert you to PDF. So I have, and this is all the Flask details, but I have basically kind of router that listens
on a port with all the get requests and put requests and takes that file. And then the important part to do is I use convert file function, which will use the OpenOffice or LibreOffice and convert it to PDF. Now, here is a thing that I want to emphasize. This is something that you can't do on any managed cloud functions today other than Cloud Run or Knative, because none of them would allow you to have a binary. You can't do it on AWS because you can't really install OpenOffice as a cloud function. And this illustrates the power of using containers as your functions or as your service, that it does not put any kind of restrictions on you. I have this binary, I don't even have its source code, and I would just install it, and I can then use it as a service. I talk about installing it. Where am I installing it? Well, I have this Docker file. So I talked about containers. I take a standard container image. I'm in this particular case, I'm taking Alpine Linux Python. And here, at this point, I install the OpenOffice or LibreOffice. I obviously would have to install, Microsoft fonts, make sure everything is updated. I copy my own files, copy, and then finally I have this command, the convert to PDF, basically, that this is my entry point to Docker. Okay, so I have my Docker file, I have my main Python file, and of course I have some HTML and all that stuff that I would need to create a web interface. So this is a very simple application, and we were talking to a customer, and this actually is a very real scenario. So they were using pretty similar to what I'm describing here for real use case, and what they were basically using it for was billing. So the customer wants to generate invoice and send it to your employees, right? Or send it to your partners or whosoever your customers. So the thing with invoice is that every time, every couple of months you purchase something you want to generate, so you basically would send a command saying these are all the data, just generate. You have a template, you create a Word, and then you create a PDF, and then you basically send it to customer. And sometimes, it's your lucky day, you make a lot of sales, so you have to have a lot of invoices, right? And there are other days where you have zero sales, and what you want is something that if I don't generate any invoice, I don't want to pay for it, right? And if I generate a lot of invoice, then obviously I have to pay for the service, but then I don't have to worry about scaling. And that's where the serverless or Cloud Run basically comes in. It scales down to 0 when you don't have any workload, and it scales to, I'm tempted to use the infinity, but of course we don't live in an ideal world. It's limited by Google data centers capability, which is a lot. So yeah, so practically infinity, but to be politically correct, not exactly infinity. But anyhow, so this is the code, and what I'm actually going to do is I want to build it. Okay, just want to make sure. Okay, I go to my folder. I have these files, and what Google, you can do a Docker build, and it will build it locally. Sorry, I misspelled the word Docker. Okay, you can obviously do that, or Google provides you with a build service called Cloud Build, which basically builds it in the cloud and then puts it in GCR, which is Google Container Registry. So that's the service I'm actually going to use here. So what I'm going to do is I'm going to say gcloud builds, invoke the Cloud Build service. I'm going to say submit. I'm going to tag, and I have gcr.io, Google Container Registry. Then I talk about my project. All right, and Barthwal Cloud Run demo, and then I have Cloud Run demo. I should have shortened the names, but never mind. So I'm now going to submit a new build to the Cloud Build service. What is it saying? Did I make a mistake? Hold on. Sorry, it's a double dash? No, I think I had the command written down here. Yeah, I was right. It's a double dash, sorry. Okay, so tech. Okay, so now I'm going to submit, and it starts building the container, and it actually will take a lot of time. And the reason why it's taking a lot of time is because you have these big binaries, right? Open Office and Microsoft fonts and all those things. So that is the reason why it's going to take a lot of time. So it's now installing everything. It's building. In the interest of time, I'm obviously not going to wait for it to complete. I obviously have built it many times before, so I can just simply go to my container registry GCR, gcr.gcr.io, and I can go to Google Container Registry. Actually, I should be able to go somewhere from here. Container. Oops. Anyway, wait a minute. Where is the container option? Anyway, so I'll show that in a while. I think there it is. Container Registry images. So this is it. So now, this was the one I built yesterday when I was just running the demo, practicing it. So anyway, I'm going to use the one I built yesterday because I don't want to wait for it to complete here. So I have this image built. Okay, let me just stop it. I don't worry about completing it. Okay, so now that I have the image built, I'm just going to say gcloud. Cloud Run, by the way, is in beta, so that's why I have to add the word beta. Cloud deploy, and I'm going to deploy, and I'm going to talk about image gcr dot, is it a single dash or a double dash? It's a double dash here. Image gcr.io slash, that's my project name, demo slash okay. So I start and ask me, where do you want me to do that? Do you want me to do Cloud Run, which is fully managed? Do you want it to run on a GKE or cancel? So for now, let me do the fully managed one. So I'd say here. And then it asks me, which zone do I want to, specific region I want to deploy. So let me just pick US Central. I don't think we have it. Probably Central is the closest. Okay, so service name, I'm just going to keep this as default, and it's deploying. And the deployment is pretty fast because once I have built the image and the image exists in container registry, then from that point of time, I don't have to wait a lot to basically for it to deploy. So now it's going to be deploying here using the command line, and it says, I've deployed it. And this now, I'm serving it in this link. So now let's actually go here. This is the service, and now I'm going to okay, so this is basically the app that I just built. And what I have is I actually have a Hello World doc here, right? So this is an MS Word. I'm showing it via Pages, but this is actually an MS Word file called Hello. It's on my desktop. There it is. And okay, the screen is clipping. Yeah, there it is. So now what I'm going to do is I'm going to say, I'm going to browse, and I'm going to pick this file Hello and upload. So okay, so it's uploading. It's basically going to send this doc file. Behind the scene, a function would be provisioned. It's get deployed, see how fast it is, and now I have a PDF file that just I took that doc file and I converted it to PDF. I can just obviously, just to convince people that this is actually happening, I just type some random stuff and I can do that. Believe me, I'm not faking it. Okay. All right, and I can do the same thing here. I can just say, ready, hello. Oh shit, it actually created, it didn't, I need to export it into MS doc file. Okay, so next, and I'm just gonna say, the new file is hello2. So hello2 now here is created, and I could, same thing. I don't actually even have to provide a file. I can just provide, sure. So let's do that again. And this time it should be quicker because that function is alive. So I don't have to provision a new function, right? So it does that. In fact, I can just, this is an online file. I can just, provide you a link like that, and this is a test document somewhere in university in UK, and same thing, test word doc. Anyhow, so I have this application running, which I used command line. Now let's actually go back and see the cloud console. So this is the cloud run, okay? This is the cloud run, and I'm going to redo the same using GUI. So now what I am doing is, let's say if I want to deploy through a web interface, I say create service. So it's going to say create service, select the container image. So let me select the one I built yesterday, continue. Gives me the same choice, cloud run fully managed, where, and here's a tricky part. Require authentication, so you can use it using Cloud IAM, because it's a cloud one, I can use Google identity, or I can just say allow unauthenticated invocations. That's what I did basically with the previous one. Anybody can call. The default is that it is actually would not allow you to call any random user. You need authentication. That's the default option. But here I'm going to make it, for the purpose of demo, I'm just going to call it unauthenticated invocation, and then I create, make sure all the fields, what are you doing? Yeah, okay, service name is correct. Make sure all the fields are correct. Continue, service name with this name already exists. Okay, I can create a new one. That's not a problem. So it's going to create a new one. So anyway, so it's creating. This was using Cloud Run, and I can obviously do the same thing on a GKE. So I can go back and I can say, well, create a service, and this time what I want is I want it on a Kubernetes cluster. So I have a bunch of these clusters available, just one of them actually. I just experimented with one. I'm going to call it demo cluster. I'm going to pick this cluster. I'm going to call it test service and external and create. Make sure, oh sorry, I didn't selected the container image. My fault, yeah. So pick this, everything is okay. Here, test service and create. So same thing. Now I'm going to show a couple of interesting stuff here. Let's go back. And first of all, I would pick the original one that I picked, which I deployed. And then I'm going to go to stack driver, and I'm going to show logs. So now this is the stack driver log. So actually I can see all the logs, latency, and everything. And here is the interesting part, YAML. What is this YAML? I mentioned that Cloud Run is completely compatible with Knative. So this is the YAML for Knative, which means if you want to deploy the same thing on your own local cluster, this is the exact YAML. You can just cut and paste and run this using kubectl, and it will deploy in your local one. So this basically is the Knative equivalent, or Knative equivalent for Cloud Run. So that's this YAML. So anyway, moving back to slide. So that was the small demo I had. Let's go back to slide. Okay, yeah. So basically there are use cases. You have a public one which allows unauthenticated requests anybody can call, and then obviously you have the private one. Let's say you have your own internal microservices. Typically people, what they have is they have different tiers of services running in a system, right? You have the first layer which interfaces with the public, and then you have the rest of these functions that you don't want people to have access to. There are ways in which you can control the access even if it's private. Which is a little more technical. I can assign what is called as a workload identity, and then I can use Google IAM and all this. So there are workarounds, but basically in a simple terms you can say that this is private. Without proper authentication, people cannot call this function. So you can have like functions public or private, and in Cloud Run you're paying for what you're using, and it's broken down into 100 milliseconds interval. How much time do I have? I have 9 minutes. Okay. So that's Cloud Run. On GKE, unfortunately, you're paying for the cost of the cluster because the cluster is running. So whether you use or not, and that's the drawback of GKE, that you still have the cluster alive. So you have to pay, it's a fixed price. So that's for the cluster. So these are some of the links for Cloud Run and Knative. Knative being open source, you have all the samples and docs for that website. There's a Slack channel. Everyone is welcome to join, have any discussions with them. Cloud Run will basically take you to cloudgoogle.com/run, but lucky that we had that URL, right? You could just get it. And that's my Twitter handle. So if you have any questions on Cloud Run or Knative or in general about Google Cloud, please feel free to ping me. And I'm up for questions. Yes, sir.
After one of these functions is invoked, does it keep a container running for a little while in case it's invoked again?
It does. Yeah. So the question was that after the function is invoked, is the container alive for a little while? The answer is yes, but don't rely on that because there's a complex scheduling mechanism, right? If somebody else, if that function is not being used and then there is somebody else who demands and that resource will probably be filled. So the way you have to basically imagine is, even if it's done, I mean, there is obviously a little bit of a cold start delay, right? But see how fast I was able to deploy, right? So there is a cold start, but even then, because the container image is in the registry, if I need to redeploy, it's going to be pretty fast.
Right, but if it's a cold start, won't it take a lot longer because we're starting up an entire Docker container?
You're deploying a Docker container. You're not, I mean, depends on what building is what takes time. Deploying is not that, but I mean, there is a cold start, yes. And if you want to avoid cold start, there are strategies of how you can do that. So typically how real world systems, serverless, nothing to do with Google Cloud, they basically have microservices and serverless running together. So I've worked with certain customers. What they have is they have these tier 1 microservices that are always running. Let's say if they have 1,000 microservices, their tier 1 would be 50 of them, and then 950 of them are the private ones. Those ones are always running, and you'll have zero cold start problem in those ones. And the remaining that you have, right, you would not have any cold start. You could have cold start, but it doesn't really matter because they are not customer facing. So a real world system basically would just not use only serverless. It will be a combination of many things. So if I was to implement it in a way that will have zero cold start, I would probably use App Engine or App Engine Flex as my tier 1 and have App Engine and App Engine Flex call the Cloud Runs, which are basically my tier 2 services. Now App Engine standard also has a cold start problem, to be strictly true, because it does scale down to 0. App Engine Flex doesn't, but it's very, very minimal because it's a standard platform, right? So we have a lot of these platform already provisioned, so we just quickly can provision. But if you want an absolute 0 cold start, it is possible that you can use App Engine Flex. Of course, understand the fact that if you have one instance always running, then there is a price implication for that. But yeah, that problem can be mitigated. Yes, sir.
Right. So the cold start problem is going to be in any
Cold start.
implementation of Knative.
Yeah, cold start problem would be in any implementation of Knative. I don't want to make a promise, but there were talks where they were talking about certain functions that not being able to scale down to 0, but 1. And
the question is how well it competes with Lambda. The second question about this is right now, is it dependent upon Istio as your API gateway to be able to?
it uses Istio by default, but if you want something else, it's an open system, you can swap it out with something else. So you are not locked to Istio.
Is it anything that complies with the Service Mesh API standard?
Honestly, I don't know the answer to your question. I can get back to you and find out. But generally, being an open system, my hunch is it's probably going to be quite compliant with open source because a lot of it is OCI compliant. So I would think the answer is yes, but I can cross-check and then reconfirm it to you.
Right, so anything that is compliant with the SMA is probably going to be okay.
It's probably going to be okay, yes. Probably. I just don't want to make 100% confirmation without checking. But yes, probably. Any more questions? Yes, sir.
What kind of events triggers does it support? Is it just that API call,
I mean, it is, calls are going to be HTTP.
I mean, I'm more familiar with like Lambda on AWS, where you could, like, a file is put in S3 and then the Lambda automatically responds.
So I think there is cloud events on GCP which can trigger, and then, so it's not directly supporting, but you can have cloud events that can trigger an event when something happens, and then that can make a call. So there is another thing that you have to put in between, but yes, you can have that scenario. Any more questions? Yes, sir.
What do you think is the best use case for this type of technology?
I just gave like a billing. So essentially, in general, anywhere where your workload varies a lot and you have a heterogeneous system where I don't want any vendor propriety, vendor lock-in. I want a system where I can have freedom of a lot of languages, frameworks, tools, binary. Yes. There could be a lot of implementation because let's say I'm migrating an existing system and I want to reduce down my cost. I already have containers, and now I'm not going to move to any Google Cloud Function or AWS Lambda because it requires me to have some kind of re-implementation. Any kind of background async tasks I can have because it's, it's event driven. When something is there to process, I can process, and when nothing is there, I scale down to 0. So there are a lot of use cases. Serverless in general is pretty broad, and this being quite open source, supporting something standard like container, for a lot of those use cases, you can actually use Cloud Run. More questions? Okay, so you have my email and my Twitter handle. If anybody has more questions, please feel free to email me. Thank you.